Hello, college biology. This is your second pre-lab video, and we're going to be over statistics. This is going to be over statistics. Your task will be to generate statistically significant evidence to support the claims that protein denature, which means we're going to have to talk about some stats. So let's do it. This video might be a little longer because there's a lot going on here. So, stats. Well, first, let's talk about math. Math is comparing and identifying relationships between numbers. We can say 5 is less than 9. We can say 4 added to 5 becomes 9. We can say 5 and 9 are odd. We can say 5 and 9 are integers. We can say if you have 5 9 times, you have 9 groups of 5, then your value is 45. But what about identifying relationships and comparing groups of numbers? What if you have this data over here, 1 1 1 1 1 10, and we're saying we have to make comparisons to that data, 3 3 3 3 3 3 4. What do we say? Is group A bigger than group B? What statements about the relationships can we make? This is what statistics does for us when we're trying to compare groups of numbers, not just one number compared to another number, but we have groups. And when you're collecting data about the world, oftentimes it's not one number you're talking about, it's groups of numbers that you're talking about. And we're going to be doing a very basic statistical analysis. It's going to involve graphing, and it's going to be a very, very low bar for significance. There are some advanced methods, but we're not going to use those. We're going to use a visual method based on some graphing, and that is by identifying non-overlapping box plots, which means we're going to have to talk about the graphing and the analysis. So step 1, generate at least 2 groups of data. You guys will be generating data in your enzyme denaturing lab, and you guys will decide what that data is. But I've made up some example data, and I completely made this up. This isn't a real study. This is the emotional response to Encanto for theater viewers. I totally just pulled these numbers out of the air. I made these up. But I said that there were 15 theater viewings of Encanto, and then we watched the audience, and then we took note of everyone who cried. So in this first viewing, 6% of kids cried. These would be people from ages 1 to 10. Then 6% of the audience that were teenagers cried. 1% of the audience who were young adults in their 20s cried. And then 17% of the adults in the audience cried. So these are percentage of demographics who cried. And we did this for 13 theaters. So we have a lot of numbers. So step 1 is generating the data. So for you, this would be doing your lab. You would be generating data while doing your lab. And once your lab is done, we need to start the statistics. And that would bring us to step 2, reorder all the data in sequence. So now this, I did this in a spreadsheet and then copied it into this document, but the percent of kids who cried, these are the same numbers as up here. I just moved the 1 to the top, then I moved the 2 2s so that they are all in order. So that 1 to 20, same numbers, but in sequence. And we did this for all of the values, because this is going to help us find the information we need for graphing, which is that information is called the 5-number summary. Step 3 is the 5-number summary. And the 5-number statistical summary includes the minimum, the first quartile, the median, the third quartile, and the maximum. So what does that mean? Well, the minimum means the lowest number in the set. Well, we've already ordered them, so we know that the minimum is whatever's in this top row because we've already ordered them. The maximum is the highest number in the set. Well, we've already ordered them, so we know that the maximum is down here. Now, the median is the number right in the middle of the set. And so we've already ordered them. So we know that that is right here. Now, the first quartile is the number that 25% of the numbers are equal to or below. And the third quartile is the number where 75% of the numbers are equal to or below. And sometimes, based on how much data you collect, that number can be easier to define. In this case, we had 15 values. So the minimum was the first, the maximum was the 15th, and the median was the 8th. You could say 1, 2, 3, 4, 5, 6, 7 numbers above the median, 1, 2, 3, 4, 5, 6, 7 numbers below the median. So the median was 8. But there's an odd number of of values here. So when there's an odd number of values, you have to average the two closest to that value. So in this case, quartile 1 is the average of 4 and 5. And quartile 3 is the average of 11 and 12. So, because if you have 8, then you go down to 7 and 2, you go down to 3 and 6, you go down to 4 and 5. The middle would be 4.5, but there isn't a 4.5, so we have to create an average. So the quartile 1 value is a 5, because it's the average of 6 and 4 for our kids' data. Quartile 1 is a 3 because it's an average of 4 and 2 for the teens data. Quartile 1 is a 12.5 because it's an average of 12 and 13 for the 20s data. And quartile 1 is a 14 for adults because it's the average of 12 and 16. And we did the same thing down here to get 16, 8.5, 31.5, and 34. That writing is just what I said. Depending on your sample size, you may have an odd or even number of values. When you have an even number of values, you must average the two closest. And that is what we had to do for quartile 1 and quartile 3. So now we graph the box and whisker plots on a single shared number line. The whiskers are determined by the minimum and maximum, and the box is defined by the interquartile range between Q1 and Q3. So this is our number line. Those who cried during Encanto. Our greatest possible value in all of this was 44. It was the biggest number, the biggest percentage of anybody that was measured. So I put my 44 as the maximum value. I could have gone on. I could have put 50 just so that it had some edge to it, and that would have been fine. But we had 44 here. And so then we do the 5 number summary. For adults, the minimum was 2, the maximum was 44, the quartile 1 was 14, the median was 28, and the quartile 3 was 34. So the interquartile range between quartile 1 and quartile 3 is the box, and the minimum and maximum are the whiskers. And so we get this data for adults over 30, young adults in their 20s, the information for teens, and the information for kids. And now we finally make claims by identifying statistically significant differences. Here's the thing. If the numbers are statistically significantly different, that means there is a reason that is causing them to be different. If there is no significant statistical difference, that means the difference between them is just random. It's just happen chance. So there's nothing really causing that difference. It's just, it just turned out that way this time. So there are lots of ways to determine significance, and we are going to do a very basic one. We're just going to look for non-overlapping box plots, and we're going to start with adults. So let's take a look. Adults over 30. Does this box plot overlap with the young adults? Yes, it does. There's a lot of overlap between adults over 30 and adults and young adults in their 20s. So we can't say that there's a difference. There's no difference between the amount of adults crying and young adults crying. Is there a difference between adults and teens? Well, we can say there is. This box does not overlap with this box. So adults and teens are different in how often they cry in Encanto. And then for what about kids? Well, adults have this box here, kids extend out here, so we can't really say there's a difference with this method. There are other statistical methods. Someone can say, well, man, that box is way shifted. There's got to be a difference. And we can do advanced math for that, but based on what we're doing, we can't make that claim. We can't say that. Based on this alone, we're not going to make a claim that there's a difference between adults and kids. So what does that mean? Well, we can't say adults are different from young adults. We can't say adults are different from kids, but there is a difference between teens. Therefore, we can make the claim that adults cry more often during Encanto than teens do. We can do that. More adults cry. Actually, more adults cry is what I should say. More adults cry during Encanto than teens. I should say that everywhere. More wherever there's a claim. More young adults cry during Encanto than teens. Fewer teens cry. I'm getting ahead of myself. Fewer teens cry. Oh, no. During Encanto than adults. Fewer teens during Encanto than an adult. Okay. So the only significant difference between adults was between adults and teens. When we do this for young adults, we get the exact same comparison. Young adults are not different from adults. Young adults have overlap with kids, so we can't say that they're different, but we can say that young adults cry, more young adults cry in Encanto than teens. For teens, we can say fewer teens cry watching Encanto than adults, fewer teens cry watching Encanto than young adults. But we can't make any comparison about teens and kids. And kids, we can't make any claims of comparisons to anyone using this method. We don't know anything about kids. Like, kids basically are the same as everybody. That's tricky. We would have to do more advanced stats to make a claim, and I'm not going to put that on you guys right now. And that is where we get these summaries. Adults are not different from young adults. They're not different from kids. But more adults cry during Encanto than teens because they are significantly different from teens, so on and so forth. And no claims can be made about kids. That's kind of what we're looking for. That's the level of stats that I'm gonna be holding you accountable to. I hope this helps. Struggle well.